What's up, everyone? Thanks for taking a quick break and hanging around for my lightning talk. Here we go. The theme of my talk is how open source collaboration helps researchers combine their individual strengths to produce superior outcomes. I'm going to talk to you about how the spirit of open source has shaped a research project that I've been working on at Google. Google's smart buildings team has been exploring AI agents to control smart buildings. This includes in a simulated building environment as well as in a real Google-owned office building. HVAC devices in office buildings form complex and changing and interconnected thermodynamic systems, which makes their operation hard to automate and optimize. Traditionally, building operators might use fixed schedules, but those are often inefficient because they can't adjust to dynamic conditions like occupancy, weather, and even electricity costs that may fluctuate. Instead, we can use more adaptive, optimal control strategies to save money and also reduce carbon emissions. One leading method for optimal control is reinforcement learning. These reinforcement learning agents learn by trial and error by interacting with an environment over a large number of iterations to maximize a cumulative reward. In the case of optimal control for smart buildings, the agent has a multi-objective function. It wants to minimize energy costs and minimize carbon emissions, all while maintaining occupant comfort. Do you like my agent? Yeah, thanks, ChatGPT. All right, so the question is, though, would you let an AI agent control an office building without any training? I see some shakes, no. And that's the role of our smart building simulator, which is the project that I'll talk to you about. The Smart Building Simulator uses a complex thermal model to estimate building energy consumption and carbon emissions, and this allows us to train those AI agents before we unleash them in a real building. Our building simulator has a few advantages over leading competitors or alternatives. One, it's a medium fidelity model that's easier to configure and use than many old-fashioned high fidelity environments. And those other environments are also slow, whereas our simulator is fast because it employs tensorized matrix operations. So we have a fast and easy to configure and use simulator. Okay, great. And we published some research about it and how to train reinforcement learning agents, and that's all great. But I'd like to talk to you about how we open source this project. To facilitate reproducible research and encourage collaboration with industry and academic partners, we open source the code for the simulator. It's available on GitHub, so if you have a browser handy at any time, you might want to head over to GitHub, visit Google/SBSim, and if you like what you see, if you support open source, you might consider starring the repo, forking it. Okay, there's my shameless plug for your repo source. I'll do it again in a few minutes. But just because a project is open source doesn't mean it's going to gain traction. So since a few months ago, we've implemented a number of initiatives to improve the contributor experience across the following areas, including documentation, tooling, automating workflows, and increasing accessibility. So I'd like to talk to you about some of these initiatives now, and you may be familiar with them on some of your open source projects. One of the initiatives that I'm most excited about is creating an auto-generated documentation site that is generated from Python doc strings. Essentially, the documentation site is generated from the code itself, which helps us reduce manual efforts that we would need to take to maintain a documentation site and the code separately. And so that's available at google.github.io/sbsim. And it gives users more confidence in the product and allows them to better understand it. We expanded support beyond Linux to include Mac, which I think most folks in outside of government use for open source development. So we're widening the universe of potential users and contributors. At Google, we have pretty strict code formatting rules, and it's a pain. And so in order to get the code merged into our internal code base, it has to follow a number of rules. And so we kind of front-loaded some of these style checks onto the contributor to make my job maintaining the code easier. And so there's a number of checks that we've implemented to make sure that the code is standardized and conforms to style guidelines. This includes creating shared text editor configuration files that all contributors can use. Part of the settings that we're sharing will automatically format files when they're saved. And this greatly reduces manual formatting efforts on the part of developers. They don't have to backspace and remove some spaces or get their line lengths right. It'll just automatically format the file. We also implemented pre-commit hooks to identify formatting issues before the submission and code review phase. So if you try to make a commit and it doesn't match the style, you'll get an error report and then you have to go fix all the issues. Finally, we implemented a continuous integration pipeline using GitHub Actions to ensure these formatting checks also, as well as automated tests, are passing before the code is merged. And these are open source best practices. All these efforts have helped drive collaboration on our project. As of November 1st, we had 83 stars and 34 forks. And I'm sure many of you are like, that's not thousands or that's not the most, but more than the quantity of contributions, we're also focused on the quality of those contributions. And so we've been partnering. The open source nature of our project allows us to partner with organizations and universities to work on the product together in the open. And I will like to talk to you about two specific success stories partnering with two of these organizations in particular. First, a PhD student from Cambridge helped us improve the fidelity of our simulator by creating a more realistic model of how occupancy changes throughout the day as workers arrive and depart and break for lunch. And second, the primary case study that I like to talk to you about is our partnership with Lawrence Berkeley National Labs. If you haven't heard of this organization, they're industry-leading experts in thermodynamics. So the open source nature of our project allows us at Google to take our strengths with machine learning and software development, mix that with the thermodynamic strengths of our partners, and combine those strengths to improve our product. And so they helped us increase the fidelity of our simulator by introducing calculations that essentially better model the way heat travels inside of the building from zone to zone. And I'm excited to announce that this work is going to be published in an upcoming conference. So this delivers on the promise of open source, how two different organizations can collaborate and publish a journal article together. So in terms of conclusion and next steps, we are going to continue our partnership with Lawrence Berkeley National Labs. And the next thing we're going to focus on is better modeling how heat from outside of the building enters the building and also heat from inside the building exits the building. So you can see the cat benefiting from the warmth of the sun coming through the windows here. Okay. But you're probably like, well, who cares about this building simulator? Our goal for the future is to enable the training of agents to autonomously control not just a single building, but a whole fleet of buildings. For example, all Google office buildings. We can also offer this product commercially to building operators to arm them with new capabilities that make their life easier so they could just kick back and let the AI control their buildings. All right. So thank you all for your attention. Your contributions are welcome. Again, that repo is on GitHub, Google/SBSim. And if you are interested, I would appreciate if you star the repo, fork the repo, and feel free to get in contact with us if you're interested in collaborating. Thanks, everyone.